delivery of project services, appreciation of the local environment, project location and characteristics. Under the guidance of His Highness the Prince Sheikh Hamad bin Khalifa Al Thani, the pioneer of advancement and leader of March Forward, the strategy of the State of Qatar was prepared to set a path towards achieving the goals of Qatar National Vision 2030. And the construction of the West Corridor falls under the above strategy. Isaroti Man joint venture are fully aware of the East-West Corridor EWC project's importance in relation with the Qataris infrastructural system, given its function as a major east-west expressway connecting the industrial area to the new Doha International Airport. The construction of the West Corridor Package 1 includes a 10.5 kilometre long section road that starts west of the new industrial area and extends to the proposed Bawa city access. 4 interchanges, IC32, IC31, IC30 and IC29. IC32 will provide a future connection with the inner orbital road, servicing the area immediately west of Doha from the north. IC32 is a cloverleaf interchange with loops in the NE, SE, SW quadrants and a directional circular ramp providing left turns from westbound to southbound. Directional ramps are also provided at all 4 quadrants for right turn movements. IC31 will provide access to the West Industrial area just north of the EWC. IC31 is a cloverleaf interchange with loops in the NE, SE and SW quadrants and a directional circular ramp providing left turns from westbound to southbound. Directional ramps are also provided at all 4 quadrants for right turn movements. IC30 will provide access to the East Industrial area just north of the EWC. IC30 is a partial cloverleaf interchange with 1 2-lane loop in the SE quadrant. Directional circular ramps provide left turns for westbound to southbound, southbound to westbound, and northbound to westbound movements. Directional ramps are also provided at all 4 quadrants for right turn movements. IC29 will provide access to the Bawa Al Baraha truck parking area to the south and connects with the Bawa commercial area to the north. IC29 is a full cloverleaf interchange with loops for left turn movements and directional ramps for right turns provided in all 4 quadrants. Pedestrian and bike paths. Execution of underpass and roadworks. Execution of the new utilities such as TSE, electrical cables, electrical substations, pump stations and telecom. Coordinating all interfacing construction works to avoid potentially abortive work. Road diversions. Demolition of existing buildings. Mobilization and management of resources for design and construction. In this project, the JV intends to perform the greater part of the works by using its own resources in order to maintain the highest levels of control over the progress and performance of the works. However, the JV shall also maintain a dynamic approach towards its strategy, where introduction of subcontractors to the project for the execution of specific and defined packages, while implementing stringent and meticulous supervision by the JV's team shall be considered where and when required. Due to the requirement of the tender to be completed in 960 days, and in order to ensure timely completion of the project, the JV has structured its site organisation to be self-sufficient and capable of meeting the project's requirements. Qualified personnel shall be allocated on full-time basis to the project and shall operate from the JV's on-site offices. The on-site team shall include a technical department headed by a senior technical engineer that will be responsible for the design activities, the technical parts of the project and the shop drawings. It will also assist the procurement department in the identification of the required materials for the project and the preparation of their packages. A planning department that will be in charge of the work scheduling and the submittals of different progress reports. A senior interface engineer who will be in charge of coordination with the other contractors, engineers and official authorities. Karama QTEL. An HSE department headed by a senior safety manager, controlling the different safety engineers and officers in the different sections, and in charge of the safety trainings and inductions, the first aid clinic, and the environmental concerns. A quality assurance, quality control QA/QC department that will be in charge of following up on the quality of the work and the materials delivered to the site. A risk manager who will be identifying, assessing, and putting plans in place for if things go wrong, and deciding on how to avoid, reduce, or transfer risks. A procurement department that will manage the purchase of material through a team that has a full awareness of the market in Qatar and already has established strong relations with more than 2,000 suppliers. The project purchasing team shall be guided by the project's vendor list and shall give priority to material manufactured in Qatar and the Gulf. On the other hand, the purchasing team connections are spread around the globe. Such connections shall be utilised to ensure the timely delivery and quality of material. Once delivered to site, materials shall be checked and stored to standards compliant with ISO 9001-2008 and OHSAS 18001-2007. Methodologies proposed for the construction that addresses the key characteristics of the project. The West Corridor P10 Package 1 will be cut into 2 sections, each one headed by a project manager, with a full team and each section having its own office and necessary equipment and resources to finish the work on time. Section 1 includes IC29 and IC30. Section 2 includes IC31 and IC32. For the proper execution and timely delivery of the works, the JV shall implement a quality assurance, quality control compliant with the requirement of ISO 9001-2008 and a health and safety management system compliant with OHSAS 18001-2007, in addition to such requirements prescribed by the client in the tender documents. For that matter, JV's strategy will be to execute the majority of the works using its own in-house capabilities, including engineering and other non-construction activities, and shall mobilise on-site qualified personnel on a full-time basis in adequate numbers which will allow the successful execution and handing over of works. Execution and delivery of the work is a large process. Here's a briefing for it. The main construction activities shall be decided by the site management, according to the execution programme and the schedules. The technical department shall prepare all the necessary shop drawings, clearly to be sent to the site for a good execution of the work. Each construction manager will transfer the information to his team. Demonstration of complete construction programme. Site installations and facilities. Prior to starting the construction, the joint venture will start preparing the site offices, the stores, the yards, and the mobile offices for each section, while another team will be working on cleaning and hauling the debris from the site premises and arranging proper access for the entire project. The following map shows the proposed location of the main construction site and of the 2 technical areas. This arrangement must be considered as a first proposal that has to be agreed upon with the engineer, and studied also in coordination with other contractors' construction sites in adjacent areas. It will certainly be subjected to changes in location and facilities disposal. Traffic diversions. A method statement will be submitted for traffic diversions, and permissions from the police department should be issued prior to any work taking place. The contractor foresees traffic diversions in full compliance with those indicated in the following tender drawings. Phase 1A. As shown in these drawings, Phase 1A would develop as follows. Traffic is to remain on both bounds of existing roads. Temporary roundabouts and detours are to be constructed. Phase 1B. Phase 1B would develop as follows. Traffic is to be diverted to the construction roundabouts and detours. Eastbound lanes from Westlow to end of West section and including other detours shall be constructed. Phase 2. Phase 2 would develop as follows. Traffic is to be diverted to the constructed lanes of East-West Main Line. Existing roads affected by the construction of the remaining sections of East-West Mainline and interchanges are to be removed. Conflicting crossing points are to be removed after all interchanges are operational. As expressly requested in the tender documents, the JV will appoint a Traffic Safety Control Officer at the commencement of the works. The name, addresses and telephone number of the Traffic Safety and Control Officer, both on-site and off-site, will be notified to the engineer, the Traffic Police and any relevant authority. The Traffic Safety and Control Officer will be a direct employee of the JV. He will be experienced in traffic safety and management on similar highway projects. Bridge and underpass construction. The works will be executed as per our programme of work approved by the consultant. The following sequence of works shall take place. Excavation of abutment and piers foundation. 20 to 30 tons excavators will generally execute excavations for structures. For hard materials, hydraulic breakers will be fitted. Material suitable for backfill will be stockpiled for reuse. Excess material will be used for embankment construction, and unsuitable material will be carried to approved disposal areas by dump trucks. If required, sloped excavations or shoring systems should be proposed before the start of works. Where the excavation extends below the groundwater table, and depending on the inflow of water, either mobile pumps or a dewatering system with wellheads will be installed. Material for bedding and backfilling will be selected from well-graded gravel. It will be placed in layers and compacted by hand-guided self-propelled rollers or tampers to 95% modified Proctor density. The excavation will be protected, and a banksman shall control the movements of each excavator to prevent any incidents. Setting out for the abutment wall and piers formwork and reinforcement work will start by using a mobile crane. After inspection by the consultant, concrete will start setting ground. Casting platform and guardrail should be provided to prevent any incidents. After casting 2 lines of piers, the scaffold for bridge deck will start, while a team will begin installing the bridge bearing. Deck formwork will then take place, followed by rebar installation for the bottom slab of the deck. After inspection by the consultant, concrete of the bottom deck slab will set ground. Reinforcement for the girder will be continued, and the displacement of the post-tension duct and tendon will start in the girder immediately. The girder formwork will be finalised with the top reinforcement, then the casting will take place. The finishing surface of the deck slab should be well completed in order to receive waterproofing protection and asphalt by using level gauge to maintain the design level. Roadworks construction methodology. The site shall immediately be secured with safety inductions given to all employees arriving to site. Earthworks. The earthworks will first commence in the road corridor to enable the utility works to then initiate. Although the road corridor will have priority, the plots area will also commence as soon as possible in a way to minimise the holing distance and allow for the subphase completion so that the client could utilise the completed areas. Clearing and grubbing. After the protection of the public utilities, the earthworks operations will commence with clearing and grubbing. The removal of topsoil, structures and other obstructions with the appropriate machinery. The debris will be removed to approved disposal locations. Items to be reused will be taken down carefully and transported to the permanent or intermediate storage spaces, depending on requirements for reutilization. Excavation in soft material. Dozers will carry out the excavation and stockpiling of soft to medium hard material in cuts or borrow areas. The loading of stockpiled material will be executed by wheel loader into 25-ton dump trucks. As an alternative, it is foreseen to utilize dozers and scrapers where transport distances are favorable. Excavation in hard rock. Rocks will be excavated by means of ripping, trenchers, and hydraulic breaking methods. If the rock stratum is sufficiently fissured or highly weathered, dozers with one-tine rippers will be used for scarifying and stockpiling the material. The stockpiled material will be loaded with other heavy-duty wheel loaders fitted with rock buckets, heavy-duty backhoe excavators or face shovels. In confined or built-up areas, excavators fitted with hydraulic breakers will be used to break and excavate the hard rock. Loading will take place with 65-ton backhoe excavators and/or heavy-duty wheel loaders. Transport of material. Haulage roads will be constructed and regularly maintained. Generally, all earthworks material will be transported by 25 to 30-ton dump trucks. Embankment construction. Before embankment, the foundations will be treated and compacted in accordance to the specifications. Soft material will be spread at the embankment locations by dozer, grader, and/or scrapers in layers up to 200 mm thickness. Water will be added and mixed into the material by grader to obtain the required moisture content. The required compaction of the layers will be achieved with 4 to 6 passes of 10 to 12-ton self-propelled vibrating rollers. Placing of sub-base. From the intermediate stockpiles and pre-mixed sub-base material will be loaded by wheel loader onto 25-ton trucks, brought to the site and dumped in regular intervals. The material will be spread in a layer as per specification by means of grader, paver, ensuring adherence to lines and levels. 6 to 8 passes with 12-ton self-propelled vibrating rollers, followed by PTR rollers will achieve the specified compaction density. As soon as practicable, after approval of the sub-base, the surface will be sealed with a layer of prime coat. Bituminous pavement. General. Plant and equipment compaction tests. Adherence to level tolerances and layer thickness will be in accordance with the specifications. Trials for prime coat, tack coat and asphalt mixes. Laboratory job mixes for bituminous base and wearing courses shall be prepared and submitted for approval to the engineer's representative in accordance with the specifications. Trial sections will be placed to show the contractor's adequacy in method and resources and to determine the application rates for prime and tack coats. Prime coat. After placing of the sub-base course and cleaning off of loose particles, a light spray of water will be applied. A prime coat of cut-back bitumen, MC70 or similar, will be sprayed with a self-propelled pressure distributor. The rate of spray will be approximately between 0.45 to 0.75 kilogram per square meter at a temperature of 60 centigrade to 85 degrees centigrade. Traffic will be kept off the prime surfaces for at least 24 hours for curing purposes. Bituminous base course. Depending on the length of haulage distance, the asphaltic material will be transported by dump trucks or tipping trailers covered with tarpaulins. The bituminous base course will be placed as per the project's specifications. 2 asphalt pavers equipped with electronically controlled paving screeds and running in parallel will place the asphalt. In areas of frequently changing widths, a paver with hydraulically operated vario screed will be used. The layers will be compacted to the specified density with 24-ton tire rollers and 8-ton tandem vibrating rollers. If more than 2 days elapse between placing the layers, a tack coat of cut-back bitumen has to be applied. Daily stop ends will be neatly cut by means of gravity-operated cutting wheel, attached to a roller or by pneumatic jackhammers for forming a construction joint. Tack coat. After cleaning of the dust and loose particles from the top layer of the bituminous base course, a tack coat of emulsified asphalt SH1H will be sprayed with a self-propelled pressure distributor at a temperature of 10 degrees centigrade to 60 degrees centigrade. The rate of spray will be between 0.15 to 0.38 kilograms per square meters. Bituminous wearing course. When the tack coat has dried sufficiently to the condition to receive asphalt, the bituminous wearing course will be placed as formerly described. This placement will be executed with the electronic level control in order to guarantee a good riding quality. The layers will be compacted to the specified density with 20-ton tyre rollers and 8-ton tandem vibrating rollers. Road furniture, finishing works and handing over. We now reach the stage of installation of all road signs, safety barriers and fencing, along with the application of road marking. As mentioned earlier, we'll be concentrating on sectional completion of the road to optimize the utilization of all resources and minimize the disruption of traffic. The handing over of all works will be in a progress upon completion of a section. This would include the testing and inspection of the works required under the specification, the preparation of as-built drawings, and the preparation of the final measurements. Street lighting and electrical networks. The work will be performed by a subcontractor that has extensive experience in similar works. The street lighting works include the connection of the pocket substation to the street lighting feeder pillars and the construction of the street lighting network. The street lighting pole foundations shall be precast, utilising our subcontractor's Abu Dhabi plant and an approved supplier. The electrical networks, including cable laying, high voltage, low voltage, will be executed by a subcontractor approved by Karama. Construction of substations, supply and installation of panel board switchgear and other necessary equipment within the substation's feeder pillars, etc. MSE walls. Mechanically stabilized earth, or MSE, shall be used for both retaining walls and bridge abutments. The contractor considers that associating geosynthetic reinforcements with subsequent embankment layers is the most efficient solution for erecting mechanically stabilized earth walls. The main advantages provided by this solution are realization, ease and speed, good resistance to static and dynamic solicitations, elimination of corrosion risk, pressure reduction underneath the solid mass, allowing the realization on compressible grounds, unlimited possibilities of geometries, variety of architectural solutions, and possibility to use a big variety of material for embankments. The three main MSE wall features are the following. The MSE wall facade is realized with T-shape reinforced concrete panels, 2 meters by 1.6 meters, 14 centimeters thick and a weight of 1,120 kilograms, together with half panels at the wall's bottom and cruciform shaped panels at the wall's top. These panels overlap each other and are connected by a means of screws, ensuring the facade's continuity. Vertical and longitudinal joints are made with tapes, and the wall's verticality is given from elastomeric plates. The facade shall easily be adapted to various possible choices. The geosynthetic reinforcements are the main peculiarity of the system. They are not susceptible to corroding and consist of a 90 by 5 mm polyester tape, protected by a polyethylene layer. These reinforcements are connected to the walls by a system of galvanized rings and screws, which are covered and protected with polyethylene. Embankments are made of natural materials of various types. Granulometrical values can vary between 0 to 250 mm, with the possibility to have only 15% of elements thinner than 80 microns. Thanks to the use of geosynthetic reinforcements insensitive to corrosion, the filling material can present a very broad range of characteristics. pH between 2 and 13, like sea sand, blast furnace, fly ashes, etc. MSE Walls construction is simple and quick, and there is no need of scaffolding of any sort. The construction procedure is the following. The first layer of panels at the wall's bottom are placed by crane on the lean concrete base, properly positioned and blocked. A first embankment layer of 0.40 meters is then cast parallel to the facade and properly compacted by means of a light machine at the wall's vicinity and by a heavier machine type V1 to V2 at a suitable distance from the wall. The geosynthetic reinforcements are unrolled and zigzag deposed, tied to the walls by a system of fasteners made of rings and screws, and then manually put in tension. The MSE wall's erection keeps moving on. In this way, embankment disposal, 0.40 meters, panels placement, embankment disposal 0.40 metres, geosynthetic reinforcements, placements, etc., till the desired height is finally reached. MEP works. The electrical and mechanical team will work jointly with the civil team to make sure that all the embedded items have been installed. The long lead items should be submitted to prevent any delay to the project. Pump stations. Each section will start the construction of the electrical substation and pump station as per the work programme. Hard and soft landscaping. This work will be executed as per the specification and performed by our subcontractor that has extensive experience in similar works. Closeout requirements, handing over and demobilisation. The successful closing out of a project is not merely an activity towards the end of the project. Rather, it is an accumulation of efforts throughout the project span. The joint venture will make sure all relevant issues pertaining to its final handover are being systematically approved by the engineer throughout the course of the project. This effort could be typically specified as follows: handing over to the concerned authorities such as Karama, Ashkal, QTAL, as-built drawings, testing and commissioning, operations and maintenance manuals, warranties, key constraint and risks to the project, programme, and how they will be managed and mitigated. Our strategy to respond to project risks is to primarily avoid them, then reduce any possible ones to an acceptance level. 3 categories of risks were identified in this project. The non-approval of temporary diversions could lead to a shift of the entire Phase 1A, which is on the critical path, and therefore would cause a delay of the entire project. The delay of the dismantling relocation of the existing overhead power lines that will be completed by August 2014 may cause the delay of the entire construction of interchanges 29, 30 and 31, those being the ones with the highest interference. A delay in supplies could cause slippage to the execution of the most important works. Proposed mitigating actions. These 3 specific risks can be mitigated by various actions. For example, the discussion and approval of temporary diversions should begin already at the stage of mobilization, in order to absorb any delays and possible changes to the deviations plan. Working closely with those who will perform the dismantling relocation of the existing overhead power lines, in order to get coordinated and organized immediately in case of delays or changes. The delays of suppliers can be mitigated only through a careful selection of suppliers and with strict control over them. Proposal for Artscape. A team of engineers will study and coordinate jointly with the consultant and the client in order to generate an excellent proposal for the Artscape. Proposal for managing the gathering of utility data. Existing utilities. The major risks involved in this project are the existing utilities, such as electricity cables, water pipes, telecom cables. Works in proximity of these underground services shall be well organised and meticulous. To avoid damaging of any utility, all the existing services will be marked by the surveyor, and different signs of different colours will be placed where necessary. Working around high-voltage cables requires permits from Karama. These permits are only given to competent persons, and all our engineers hold an LOA and are certified by Karama to work around HV cables. Utility construction. This part deals with the construction of utilities that include electricity, street lighting and telecommunications, drainage, potable water and firefighting, telecommunications, irrigation pipelines, structural and electromechanical works for the pump stations, irrigation, etc. After reviewing the typical road and service sections, the critical items that are required for the completion of the road works are the storm water drainage lines, since they are near to the road edge. Accordingly, the above-mentioned utilities are to commence as soon as the road formation is completed, along with the entire service crossing under the roads. In areas of existing public utilities, location plans will be obtained from the authorities. Trial trenches will be dug, and a survey will be conducted. All activities will be in accordance with existing regulations. In areas where the consent of the authorities has been obtained, the relocation, protection and new construction of the utilities will commence. The proportional division of own activities, specialised subcontractors' works and public service authority works has to be determined through the course of the construction. Major excavations will be carried out by managing health and safety. Our approach to health and safety management dedicates the implementation of the following guiding system, complying with all legal requirements, i.e. Qatar labour laws, QCS 2010, environmental law and regulations, being proactive, adopting best industry practices, implementing robust and smart approaches proven to be effective throughout our previous projects and getting us many awards, generating a project-specific HSE plan and procedures through well identifying the scope, creating WBS, risk assessment and job hazard analysis. These HSE plans were adopted in several previous projects and were tailored to the proper satisfaction of all stakeholders, displaying the monitoring of risks through risk speedometers, building teams of skilled and competent personnel in respect with competency requirement matrix. Our teams have constantly proven their ability to achieve their targets. Deploying adequate plant and equipment with planned preventative maintenance schemes. Having a comprehensive safety checking, training, reporting and monitoring system for all aspects of safety, traffic, construction, environment, fire, welfare, plant and equipment. Assuring that both internal and external audits are carried out within a defined schedule, preparing and training our teams for all emergency cases. Management of quality, health and safety. JV is committed to provide a healthy and safe environment and shall thus implement a health and safety management system compliant with OHSAS 18001-2007. This is achieved by carrying out suitable and effective risk assessment. When a complete understanding of the scope work and Level 3 schedules is achieved, a safety WBS can be elaborated. Major packages will be subject to qualitative risk assessment and will lead to determine the activities that need specific job hazard analysis. The JV will not reserve any effort to prevent accidents on site. Effective actions and resources will be deployed to obtain these objectives in respect to international standards. The JV will also give high importance to the environment. Therefore, during the construction of the project, we'll adopt all the necessary actions and efforts to minimize the generation of construction waste and will handle properly the generated waste. We will ensure that the noise regulations of Qatar are being complied with at all times. We will take the precautions and measures necessary to prevent excessive dust annoyance. Gate passes will be provided for all staff, workers and visitors to access the site premises. The JV shall prepare a quality system with the following elements. A contract quality plan in accordance with the requirements defined in the tender document. A system of records which shall provide objective evidence that the contract requirements and mandatory rules have been satisfied. A system of technical procedures, work instructions and method statements to ensure that the project is completed in compliance with the contract requirements, mandatory rules and Qatar National Construction Standards, QCS. A system of inspection and test plans in accordance with the requirements defined in the tender document. A system of internal audit programs in compliance with the requirements defined in the tender document. All of these documents must of course be approved by supervision consultant. Finally, the JV defines the methods and criteria through which an effective surveillance of the works performed by these subcontractors is provided. Constructability and approach to value engineering. A value engineering program will need to be drawn up which identifies all of the studies that are anticipated to be carried out. The value management program is typically developed and agreed upon with the client and the consultant as part of the project execution plan prior to the construction. All those involved must be fully committed to the process, which requires preparation and clear communication. At the start of the VE program, a workshop is held where options are identified for further study. Cast models are a useful tool to identify where value issues need to be addressed. Our target is to simply give you what you have seen in this animation. An excellent quality of work, a very precious artscape and landscape, and a non-compromising level of proficiency.